To engage with dairy at South Dakota State University is to participate in complete farm-to-table, state-of-the-art dairy processing. Students in the dairy science program supplement rigorous classroom time with hands-on experience. Students learn how to run, maintain, and manage a dairy plant. They make cheese, process skim and 2% milk, and make ice cream and other dairy products. The SDSU Davis Dairy Plant was opened in 2011 to include the latest innovations and technology in the industry. The 17,900 square foot plant features a loading station, receiving room, milk and cheese processing room, ice cream production room, a -20 degrees and -40 degrees freezer, and a one-of-a-kind dry ingredients processing room. The dairy plant processes approximately 10,000 pounds of milk a week
and employs more than 20 students part-time.
The dairy plant undergoes quarterly inspections conducted by the South Dakota Department of Agriculture to assure that high-quality dairy products are processed and sold. Students learn the latest farming technologies, from feeding to milking to animal care and farm management, at SDSU's dairy farm, where the whole process begins. At the SDSU Dairy Farm, students care for and milk about 140 cows per day, producing over 80 pounds of milk per cow per day. Raw milk arrives at the SDSU Dairy Plant via tanker truck from the SDSU Dairy Farm twice a week. The raw milk is pumped into one of two larger holding tanks, each holding up to 6,000 gallons of raw milk. A student changes out a stainless steel elbow to ensure that the raw milk is routed from the raw silo to the pasteurizer. Students are responsible to clean, check, and change out any number of given stainless steel supply lines during dairy processing. The entire system is automated. A student begins pasteurization at the computer control panel. Prior to pasteurization, water and sanitizer are washed through the entire system. The water level is lowered in the balance tank, and raw milk is routed to the pasteurizer. A 4-minute timer is set to ensure all the water is flushed out of the line. The raw milk is pasteurized, heated to 165 degrees for 24 seconds to eliminate any bacteria in the raw milk. From the pasteurizer, the milk is routed to the cheese vat. The pasteurized milk is routed to the cheese vat via the computer control panel. The student visually checks that 2,500 pounds of pasteurized milk enters the cheese vat. The cheese vat takes approximately 30 minutes to fill with pasteurized milk. We are ready to start making cheese. At this point, samples are drawn of the pasteurized milk from the cheese vat to be tested for milk fat content and to test the beginning acidity and pH of the milk. In the lab, the student tests the milk sample drawn earlier for titratable acidity to see what the level of acid is in the milk. The acidity and pH levels are monitored during cheese making to ensure optimum taste and texture. This test is done several times during the cheese making process. The student then records the amount of titratable acidity. Starter, rennet, and color are added to the cheese vat. Type and quantity of these ingredients depend on the desired type of cheese. Today, we are making bacon cheddar. The student begins by adding a starter culture, a living bacteria, to the milk. The culture feeds on the lactose in the milk, producing lactic acid. This acid lowers the pH and increases the acidity of the milk. This starter culture is essential to turn milk into cheese. Next, coloring is added. Cheese is naturally pale in color. A natural color agent is added to make the cheddar and Colby cheeses orange. After the cheese vat is full, an ingredient called rennet is added to the mixture. Rennet is an enzyme that coagulates the milk till it appears as the texture of white jello. The mixture will sit and firm up for 20 minutes. While the mixture is setting, students prepare the cheese drain table to receive the product, which will enter as curds and whey. The table is adjusted to accommodate the volume of cheese being made. Once the desired firmness is achieved, the solid mass is cut into curds and whey, agitated with rotating paddles for 35 minutes. The curds are the solid chunks, and the whey is the liquid that is extracted when the mixture is cut. There are multiple cuts, where the set is cut for several minutes and allowed to stand, and then cut again. After the mixture is cut, it will be cooked up to 100 degrees Fahrenheit in the cheese vat, and then pumped to the drain table. The whey is drained from the curds while the pH level continues to drop. The cheese curds are smaller and still very soft at the beginning of this step. Rotating nylon paddles keep the cheese curds from clumping and allow the culture to continue to feed on the milk sugar and lactose and produce lactic acid. The curds remain on the table for approximately 90 minutes, and the pH level of the cheese is checked several more times. The cheese curds are broken down on the table to a more uniform size. The curds are quality checked for size and manually broken up if necessary. When the desired pH level is achieved in the cheese, a student adds salt to the curds. Salt is added for flavor and to slow the starter culture. The culture doesn't like the salt, so this marks the shutoff point for the enzyme activity. The amount of salt is measured and determined based on the amount of cheese that is being made. And because today's batch of cheese will be 210 to 220 pounds of smoked bacon cheddar, smoked bacon bits are added to the cheese curds. The salt and bacon bits are thoroughly mixed into the cheese curds. SDSU also makes a pepper jack cheese, adding jalapeno peppers to the cheese at this point. The paddles are removed from the drain table. The final step at the drain table involves hooping the cheese, packing the cheese curds into 20-pound blocks using stainless steel forms called hoops. The hoops are uniformly packed, ensuring a nice, even final block of cheese. The filled hoops make their way to the cheese press. The hoops are stacked in the press. The cheese is pressed overnight with 80 pounds of pressure per square inch. The next day, the cheese is removed from the hoops, shrink-wrapped, labeled, and placed in the ripening cooler. The smoked bacon cheddar cheese that is being made today will age for 3 to 6 months. The color of the cheese will get deeper as the cheese ages. After the cheese has aged, students cut the larger blocks and package the cheese for resale. A student changes the connection on the piping system to route milk from silo number 1 to the separator. Milk for all products except cheese goes through the separator. The milk separator will separate the cream from the whole milk. The student will begin the separating process for the whole milk at the computer interface. Whole milk is characteristically 3.5% milk fat. Ice cream is closer to 13% milk fat. The fat, or cream, will be separated from the whole milk and routed to a holding tank. The remaining skim milk will be pumped to a separate tank. The cream and the skim milk will be used in the ice cream mix and fluid milk processes. The separator works like a giant centrifuge. The separator will process 7,500 pounds of whole milk per hour into skim milk and cream. After the milk is separated, it goes into the pasteurizer and from there to a pasteurized milk holding tank. Students prep the milk filling machine. Raw milk that isn't pasteurized for cheese is separated into cream and skim milk. Skim milk is packaged in 5-gallon bag-in boxes for food service use on campus, in various cafeterias and other food venues. Daily milk deliveries are made on campus. SDSU also bags 2% and 2% chocolate milk. The cream that has been separated from the raw milk is held in the cream tank. The cream is agitated to keep it cool at a constant temperature throughout the tank. A student takes samples of the cream to test for the percentage of fat content. After the cream tank is filled, a student washes the separator and the line from the separator to the cream tank. The student takes the cream sample to the lab to test for fat content. The percentage of fat content will be used to calculate the ice cream mix. Then the cream is transferred to the recon tank. This is where ice cream mix is blended. The ice cream mix is accomplished by blending cream with a smaller portion of skim milk. Some of the cream is pumped from the cream tank to the mixing room. Dry ingredients, sugar, non-fat dry milk powder, stabilizer, and dry corn syrup are blended with the cream in the mixer. The mix is pumped back into the recon tank to be blended with the remaining cream and skim milk mixture. All of the ingredients are thoroughly blended and pumped back to the pasteurizer. The pasteurized ice cream mix is pumped to a holding tank in the ice cream finishing room. The mix stands overnight so that fat globules can crystallize. The ice cream mix is pumped to the flavor tank where various flavorings are added to make the more than 60 different flavored ice creams that SDSU offers. From the flavor tank, the ice cream mix is chilled to freezing. Once the mix is frozen, inclusions are added to the ice cream from the fruit feeder. This machine adds fruit, cookies, peanuts, or whatever inclusion a particular recipe requires. The Revel pump adds strawberry, marshmallow, hot fudge, any type of swirl ingredient to the ice cream. The final product is pumped to the filler machine. Students manning the filler machines pump ice cream into individual plastic pails, 1/2 and 3-gallon containers. The packaged ice cream is placed on carts and wheeled into the blast freezer to settle for a couple days. After the ice cream sits in the -40-degree blast freezer, it's stored in SDSU's -20-degree freezer. The state-of-the-art equipment in this room replicates the type of operation found in the industry, only on a smaller scale. The dry ingredients room features a 2-stage, 7-pass falling film evaporator. To make non-fat dry milk, the process begins by pumping skim milk to the top of the evaporator, where it falls through tubes in a chamber held under vacuum, which lowers the boiling point of milk, allowing water vapor removal without affecting milk proteins. This happens 7 times until the majority of the moisture is removed from the product, resulting in concentrated skim milk. This concentrate is pumped up to a spray nozzle at the top of the dryer. The product is sprayed into 400-degree heated air where it falls through the dry heat to the bottom, resulting in powdered milk. The dry product is pumped back to the top to a series of sifters to create a uniform particle size. This facility is perfectly suited for trial or test runs for dry ingredients. It is used by the university and industry for research and production. It is one of only a few such operations in the nation. The dry ingredients room has processed egg powder, cereals, corn syrup, sugar, cheese, and milk, dairy and non-dairy ingredients. A lot of important nutritional ingredients come from milk. The dry ingredients room at the Davis Dairy Plant helps to expand the value of milk and whey. In addition to staffing the dairy bar, SDSU's on-campus retail ice cream venue, students are involved with creating new ice cream flavor profiles and packaging and promotion of SDSU dairy products. Students also learn about product pricing and distribution and store management. If you are a student or an alum of SDSU, chances are that you've already been to our dairy bar. We are the place where cookies and cream ice cream was invented and home to one of the nation's top dairy science programs. We invite you to Brookings, South Dakota to see and taste for yourself and be a part of this exciting field.